Hello and welcome back to another fine evening of Rust where we'll be competing in the Hypersonic game, getting past the Silver League and doing some AI, probably searching, but first let's go sign up for our typical Clash of Code, wherever that is. We get a game started here. For those of you new to the show, we are doing Rust programming, primarily AI programming for little robots on the site called Code and Game. And we're currently competing in a Bomberman style clone where we have to move our guy around and bomb and not get bombed ourselves. Last show we just basically set up our simulator. That's what sets up the game. We start the show with this Clash of Code, which is a very quick competition, and we sometimes do well, sometimes don't. We either have the quickest mode, reverse mode, where we have to decipher something, or the Code Golf mode. Code Golf, we don't do so well in Rust, but that's okay, that's not our concern. The fast ones are some guys that are like super speedy on this one. They're really great. They're just like, I don't know how they read that fast. And once we get through this, then we'll go over to back to the code for whatever it is, Hypersonic. I keep forgetting what it is. For those of you watching earlier today, I was doing leaf programming, and leaf programming and alternate back and forth between this show and the leaf show. And if I get the leaf graphics far enough and simple enough to use, I'll start explaining the algorithms we use here over in the other show. It won't focus on leaf, focus on algorithms, so we have a good segue between the shows to keep it interesting. Because a lot of the algorithms we're using here, also the one we're using today, is very hard to visualize without actual visuals. So in your head, it's a bit hard. Alright, so we're waiting for one more play and then we'll go. These fill up fast normally. Alright, we'll see what happens. Whether I can talk or not depends on how complicated this one is. And oh, we have reverse mode, so we test and we have to see what comes in. A, B, C, Z, what? Oh, this is a bit weird. What the hell? Lose. Well, that one's weird. A, B, C, X, Y, Z. It reverses them. This reverses the whole thing. And this one reverse. What the hell is going on here? Codinggame.com. So there has to be some sort of conversion here. These are the same letters, so these are offset somehow. And this is reversed. So some are offset and some are reversed. No, I bet it's Z minus. Yeah, I got it. I have a good idea what this is. For C in word.chars. I don't know why I typed that. Let num equals C as you ate. Let O equals Z as you ate. Minus N. I'm going to do a print here on O as char, I think, and then we'll just put print line at the end. I'm hoping my guess is correct, otherwise we're going to have to figure out something more. Print I forgot. Oh yeah, this was silly. Print, this is a macro. Found nothing. We did find something. How did that print nothing? ePrint line Word. What's in Word? That's the Word, so what's in Word.chars? ePrint line C. Oh wait, this is supposed to be Z minus N plus A. Maybe it's printing a bunch of zeros or something, a bunch of characters we can't see. You ate. That looks good. I think we're good. I think I got a good lucky guess. Alright. We might do well on this one. We got a lucky guess. I like that. This is the first time I think we've come in first by one that wasn't like trivial and we did really fast. So I just had a good intuition here about what this was. And so basically the input, the output, if you understand show, it showed us the output, and we had to guess the algorithm based on the input and output. And this is just basically Z minus the letter in the ASCII alphabet. And that was super quick. This one was exciting. With this, I don't know, this one was actually... How do you mark these things? Is this hard or not? I just had a good intuition. Test cases, they were good test cases. They really gave away what the issue had to be. Okay, I'm going to turn off my proxying for a bit so we can get the show. Alright, took him a bit longer, but he pretty good, and... Oh, and he just hard-coded the other one. Oh, he do it... Okay. He was just guessing, so I got... That works the same way. Does the basic thing, that's the plus A. Alright, so let's go over to compete in any case. We're going to go compete. We'll let that finish off, and we're going to go over to the Hypersonic. For those of you new to the show, the Hypersonic is exactly this. We have the little Bomberman one, and we're programming these robots. And we're trying not to get killed. That's the big one. So some of the people on our show that are playing this, we know Euler's run, Ion Codes is there, and Karais here is doing pretty good. He started with us last Friday and he's working on it. He's doing pretty well here, so we got to catch up there. Our Silver League bot is really kind of stupid right now, and well, beyond stupid. He's not even programmed correctly. I think we do one level of depth. We bomb ourselves right away if you want to see what happens. So watch, we're going to bomb ourselves right away. Yeah, we're not, you know, we're not the smartest robot at the moment. But we'll see where we are. Turn on the external editor, go over here, use previous selected file, upload it. And I'll let you know, I'll give you a listing of tools of where we are. So if you want to do the same stuff and you want to use Rust or any other language, you can. Use some of the tools. I mean, the biggest one we use is the Jasper's external editor, and ePens also has the source builder for us, which lets us use an external editor, and we're using Visual Code for that. Visual Studio Code. It works well enough for this. It's not my favorite thing, but it works. Now, our entry point, last time we converted it to say get my best turn. And get my best turn is where we're focusing on right now. Get my best turn is right here. And we do one depth. We take all the turns that we possibly have, turn offsets, and with or without a bomb. And then we step through them when we think, all right, are any of these any good? Can we... But now we have to go a depth one down. These are the thinking yoga balls. If you see me playing with them, I have a collection of them on my desk, you know. It's good to have things around to think. People make fun of me for thinking with them, but if you think I pick it up and look at it, think with the play, because I'm deep in thought, which is a bit hard to do when I'm thinking. I also have a little owl here. This one's from my daughter. The owl is really cute. And I can watch him all day. Usually I program with music, but I can't on the show. Unless somebody wants to give me a bunch of royalty-free music I can play on the show. And then I actually like. That's the other one. Alright, let's go through this. So we get best turn. What we have to do now is we have to make this go one level deep. So we want to make a stepping function. We want to do stepping function, not public. This is not public. And this is going to be iter best turn. And this is its starting point, state. And what do we want to do? We want to do steps. How many steps left? How many remain? How many steps do we have? And this will just be an I32. And it's going to return a turn back. Well, a turn with a score. Turn an I32 score. Okay. And maybe it should return optional. Well, we're just going to leave it this way for now. We're going to leave it. We have this scoring thing, get score. We'll return a negative score. That's fine. So it's going to be a bit ineffective right now. But we'll just do it that way. We can if we do a few turns deeper. So in this turn, we're going to have basically the same loop as this one here. And we'll worry about the duplication a little bit afterwards. For now, what I think I'm going to do is I'm going to turn off the bombing. I'm going to say basically only let us bomb in the first turn, or shall we just go through all of them? It's good to bomb in this turn, we don't know. And I don't know yet. I don't know whether it's good to do this, because we don't want to go too depth far down, but I'm trying to think of what we do. If we prune too quickly to start with, let's just take it off for now. Should be good enough. This means we'll only ever place a bomb on the first move in our exploration, which should be good enough. I mean, it's obviously not good enough, but it will give us something. A bomb will be false. And that means the first level iteration can turn bomb on or off, and the next ones will always turn it false. And so here we're looking through all the turn offsets, and these are up here. These are all the positions we can move to. And if it's not a valid move, we just skip over that turn. And I wonder, best turn, I think this has to be an optional. Because it's possible we have nothing left. It's possible there is actually, it's a real weird course of events, but it's actually possible that we have nothing there. So, if best turn is some, then best turn, no, then we return best turn dot unwrap best score, else we return none. Okay, and for each of these moves we're going to take the turn, we're going to duplicate the state, and this is really ineffective right now, and we apply it, player owner turn, we apply the state onto the duplicated state, then we get the score of it, and I can skip this part out, I think we're okay with that. We're going to skip the dumping of the state, and we're going to get the best turn out of each of these. We're not actually, sorry, we're not going to score it yet. That's correct, we're not going to score it yet. What we're going to do is we're going to call best turn if steps is greater than 0. This is where iteration goes. Otherwise, we're going to do it this way. No. Let me just do both first of all. If steps is greater than 0, our score comes from let's score equal. Actually, let's score. Yeah, let's just say R for now. Let's R. No, we'll do let if. Is it let if or if let? If let some turn comma score equal best turn dupe state this takes a reference to it. You could probably actually just take it over. We don't need the state back. But it makes no difference here. And it takes steps -1. And then this has the same basic loop. It's really a bit weird. It's okay. I'll just duplicate for now. We'll figure out how to get rid of the duplication later. It's unusual I have no chat. Or can somebody just say hi just to make sure that the chat's working? I'm going to deck it over here as well. We've had this issue once before. You don't need to chat, just private period or something, and I just want to know that the chat's working. If best turn equals none or scores, but return score equals some turn, best score equals score. So we can probably duplicate there. So we're doing one step down. Hi, Kreis. And I see your bot's doing really well. You're up to pretty high in the gold league. And okay, so now we've got that established. Chat's working. It's not very chatted today. That's fine. It's fine. Mine bugged. Okay. All right. So I have to iterate this best turn now, and so the score now is going to be this. Our score is going to be if let some turn comma score equal iter best turn. You haven't worked on it for a week. I mean, that's fair. I mean, these things take time, and we don't have a huge abundance of time. I tend to work it all on the show. I worked on it on Thursday as well. I'll let you know when we catch up to you, though. We will catch up to you, and then you'll have to work on it again. And we'll both make it to Legendary League then. Shouldn't be too much harder once we get this thing working. Exactly. As soon as I pass you, just by one. If I'm just sitting ahead of you at one, you have to pick it up. I'm assuming I have a performance issue thing here, but we'll deal with it then. So dupe state. Give it a dupe state here. And let's start the iteration count with 1. Let's just go 1 deep and see what happens. I just want to see if it works well enough. And it scores it turn, comma score. We're not going to dump the states. And it may not have a best turn, which would be frightening. And what happens if it doesn't have a best turn? If best turn that is sum, we'll return that. Best turn dot unwrap. And this is just unwrap or. Sorry, best turn unwrap. Unwrap or turn. Position's going to be player.position bomb false. Do nothing. It tends to be very rare that we have this issue where it actually can't do anything, but just for correctness we'll do it. Let's go clear and cargo build. Oh, we got weirdness. Boolean. Oh yeah, whatever. Fine. Where did I put the Boolean? Is entity on within range? Oh. You know, I started coding something last week, and I forgot what it was. So, I might have broken the code, because we were actually working on something. Hey, Christ, I know there is an is none. I know there's an is sum and an is none. And I'm just trying to avoid using them. Like, I have an is sum, and I'm trying to find ways like this where I'm trying to make sure I make use of the standard library as much as possible in Rust. So if I'm just going to do an if else on is none, it seems better to use like unwrap or instead. Cannot. Okay, 260. We're not in a loop. All right. So who's calling this is entity within bomb range? Right there, and that was part of the boxes within bomb range. Is entity within bomb range. And this is going to be return false. Oh, where do I have that? I certainly don't want to have an equals none. Oh yeah, I do. Oh, that's where you meant. What's the preferred way of doing this? I've been using is none a lot. I've been using this and just not thinking about it. Is none. I'm just used to that pattern. The reason why I didn't equal is because usually when I do this pattern, if I do it in another language, this is probably a pointer type, and I can't call members on it. In this case here, it's definitely an option type, and so I should be able to call it. So, yeah, we'll just do it that way. That makes more sense. But option has partial equals defined on it, doesn't it? Or does it require the type inside to have partial equal as well? Okay, so we'll stick with is none. That seems, if that's more correct, we'll do that. And return false. I'm not sure where the code was last time, so this is a bit of a problem. We started creating is entity within bomb range, and I don't remember why I did that. While lag on Twitch today seems to be really poor. I had that earlier in the stream day too. There is like a huge lag with people chatting, and I'm getting really ahead of people. Let's this is this weird construct now. Don't I need to have this? Yeah. That's awful. And what else do we have? All right, good to know, guys. I'll assume people, you just have to type things too, so it makes the lag seem longer. Because the moment you're on it, it's the curse of Twitch. Somebody said something, you first have to register it, then you have to figure out where is your chat window, then you have to type something, press enter, and then you get the lag on top of that. So it's not exactly 100% interactive, but it should work well enough for coding. And what do we have? We have found tuple 3237. This has to be sum. Just double parentheses. Unused variable player. That's a bit weird, but okay, we'll leave it for now. And I have to check out what was I doing for this? Boxes within bomb range. Boxes within bomb range. Get score. So we add all the boxes. This is to add a partial score. We never actually tested it last time. Ooh, so let's find out. We already did that. Let's find out if this does something. We do 2 levels deep. Let's hope we don't time out. Let's hope we don't crash. Let's hope we don't bomb ourselves. So we don't actually place a bomb, which is an issue. We don't bomb ourselves, which is a positive thing. This is the results of the 1 out of 8 in the clash of code. So whether this is better or worse than before, we don't know. We're not placing a bomb ever, and so we can pause this and we can look at the scores that we have. We have these scores, and we don't have bomb true on any of them. And oh my goodness, I know what mistake I made. This is the stupidest thing. I can't imagine this. You're not going to believe this. Iter best turn doesn't return turn. It just returns an optional score. It doesn't need to track the turn because it's the top one that has the turn. And so what I was doing is I was placing the leaf turn. I was taking the leaf turn, but I want the top level turn. So I just did something really stupid. So we get rid of this best turn here. We have to create the turn, and best score equals none. Best score is none, or score.unwrap. No. Unwrap. Best score equals some score. Okay, otherwise, just technically did that turn, should the turn get score if best score is none. Or score is unwrap. We could probably just use an int minimum there instead to simplify, but that's not my biggest concern right now. Some score. And so now we can literally just return the one value, just return best score. So that was a mistake I was making. I was returning the leaf node. So we're going to returning the leaf turn, which is wrong. I'm supposed to return the top level turn. Of the top level turns, what values, what are the scores of those turns, and take the first turn, obviously. And I have to build this as well. 219. We can control click this, I think. And this was iter best turn, let's sum score. There we go. Best score.map or true. Looking at syntax, what syntax do I, or Alright, I got it. So map or true, this is even better comparing to none. Or S scores greater than S. That looks cleaner. So this replaces the if and just says, look, we have a conditional if and yeah, I got it. Just took me a few seconds to understand what was going on. The condition basically is, it says we're doing a map or, and this is an optional, and it has two options. If the optional is not set, it maps to this value. If the optional is set, it gives it to this closure and says what this value is. So here we're saying we're going to set best score if it equals either one of these. And we can actually get rid of the... We can probably get rid of this if as well, since we're... Actually, no, we'll just leave it. We might reassign. Then you'd have a max. Let's just do this. Forget about it. Ignore my rambling. And let's see if this actually plays something now. My bot actually walked around, it looked like, which is weird. Okay, do I drop a bomb? Oh man, I still drop a bomb right at the start. And what am I doing? So what are the scores here? So dropping a bomb is worth more than not dropping a bomb. Because I don't consider being in a bomb range to be bad. Alright, so the reason here is that well, let's see how far I can do this depth first. Let's see if I go to 3. Let's see if it actually takes too long to execute. It probably could. I'm probably still going to walk into the bomb, but I can see different scores at least. And alright, so what do we have? We have these place bomb, 1 score, 1 score, 1 score. And this is the issue, we're going to place a... Wow, well, it's good that we can evaluate that far into the future, but now we have to basically say, look, if there's any bombs within range... If there's any bomb within range, we're just going to consider it a scary ending state and go, ah, scary. Never do that. Which means we have to evaluate far enough ahead to get out of range, which is an issue. And where is our scoring then? And that's what I'm concerned about with this, with the bombs. The bombs are kind of scary that because they have a range of 3 and because they have a countdown of 8, you have to use some trickery here because we cannot afford to go 8 steps in the future all the time to actually see we're going to explode. So we're going to have to basically say, look, if we're within range of the bomb, just don't place the bomb. And the bombs have a range of 3. Well, technically 2. They just measure funny. Yeah, it gets worse. I know it gets more than 3. It gets up higher than 3. As you get items, it gets worse than that. But the countdown was always 8. And where's my score? So my score here is... Now I have to say... Now I want to know if the bomb is within my range. Okay, can I make a marker here? A marker. Bookmark. Is entity within bomb range. That's what I want. That's why I was writing this. Is entity within bomb range is something I want to write now. Is entity within bomb range 2, and this is supposed to be a bomb. Bomb. Now I remember what I was writing. Bomb. 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 Alright, is entity within bomb range? No, what have I done? What the hell keystroke is doing that on me? Alright. If is entity within bomb range, and we're going to say state, and state, that's us, state bomb.position, and the entity is us. If we're within range of the bomb, then score minus equals 100. That's bad. I can't completely make it all the way minimum because then we'll never place a bomb. But this will prefer things where we're not within range. And let's give it an and player entity. And we placed the bomb. Why are we not going down, though? Okay, so we actually placed the bomb somewhere out of the distance now. And we had a bunch of ones where we died. And we had one where we went down. And it had a positive value. So why did we not choose that one? We did choose that one. Move 0, 0 is 11. 0, 0 with a bomb is also 11. We didn't have a bomb. The other moves are not valid, so we move to 0, 11. And now our options were in this position, we were also still in that position. Where were we supposed to go? Move 1, 0. Right, that's bad. Oh shit, you know what it is? No. It didn't see the bomb there. So it's taken the one where we move 1, 0, which has a score of 11, and as opposed to one down, and it's not seen that there was a bomb there already. But there is a bomb there. So we have something wrong in the code there. There is a bomb there, definitely. And it failed to see that bomb. Why? That's wacky. Huh. Let's just do some debugging here and figure out what it is. And we'll put a boolean here as well. And we're going to say bomb.position and Q. Q. Let Q equal. We might have to go back to our test cases. We have. No, I pressed play. No, I meant to press reload. Remind me not to do that. And look, he's doing something halfway intelligent now. This is almost scary. Dead. Oh, crap. So we're timing out. Yeah, well, that's a problem. Let's go back to one where we don't time out, where we bomb first. We know we might time out. We're going to have to deal with it, but if we can't go 3 depth, we're going to have a problem. Right there. Why did we walk back into the bomb? Why are there so many bombs on the board? Oh yeah, because we consider all those iterations. That's fair. Lots of iterations, and what do we move before that? We chose to bomb 0,2. Well, crap. It's gonna be, right? Like, we do some things, and right there is the one I want to investigate. Why did we sit there really poorly? We saw that there was a bomb there, so why did we move towards it? Move to 2, 2, 0. These are both fully negative values, so those are really high negatives. And what were my other options? Move to x 0, 0, and that has a value of 12. Okay. And then move to 0, 0. Because it was too late. Why was it too late, though? That's fine if it's too late, but we shouldn't have been there. We shouldn't have been anywhere close to that. And we chose the bomb. Well, let's simplify this first of all. If there is... if bomb, and let's check if there is a player bomb on the board. Has player bomb. We'll just simplify this for first of all now. So we'll never drop 2 bombs. That'll at least save us from that one basic problem. Because what we should be doing here is we should actually be tracking if we can drop multiple bombs. But because our range is so small, we might not be able to do that. Has player bomb. State and state. And here what we're going to do is we're going to do a state.entities.iter.find entity.what equals entity type.bomb. And int.owner equals state dot my ID, and we say is sum. It is. There might be a has function or something. And at least this will prevent us from placing that double bomb, making it maybe not so retarded. But it's not the full solution. There's still a bug here, and I'm hoping it narrows down, and maybe that is the bug there. So what I understand, this is a perfect case right here, so let's go to options and switch it to manual mode so I can't screw it up. Why am I walking back and forth there? And that's the question I want to determine, move 3, 0. Why on earth did I move to 2, 0 the turn before? Because 2, 0, it should have been a bomb within range. And 3, 0 has a score of 11. And 2, 0 also has a score of 11. That's obviously wrong. So we're not catching the fact that the bomb's there. Why are we not catching the fact that the bomb is there? 2, 11. Oh, this is, I understand why. Because we're evaluating all these possibilities, it's found that in the 2, 11 one, it's found possibilities where that's okay to walk to 2, 11, where we haven't actually died yet. So that's a curious case. How do we evaluate that? Every single step we have to evaluate, are we dead? And short circuit it. So we're going to have a special one. So we have to prune the tree. In any case we might die, we absolutely have to prune the tree and say there's no value down there. So we're going to have a special one here called public function. Not public. Why am I calling these all public? We don't need to have them public. I'm just going to stick it. Function. Let's say likely die, so we can give it some wiggle room. And state. And bool. And we're going to do this. We're going to do the bomb thing here. If we're dead, then we're dead. If the player's not alive, then obviously we're dead. That's a very clear case. That's a very case of dying. Likely die, return true. If the player's not alive, then we've likely died. So now we go through all the bombs, not just the one the owner has, which we've done, and we say, is the bomb within range of the player? So if the bomb is within range of the player, we're also going to return true and say, look, we've also died here. Otherwise, false. Otherwise, we have a condition where we don't actually die. And so now when the gut must my turn, we can do some pruning. And we can do it at the top of iter best turn, because it's going to do it right away. We can simply do right at the top of his turn, we can say if likely die and state return none. Then there's no option this way. If we likely die in that one, where is not what they want to like? Likely. What's true are you talking about? You mean here, or where do you mean it? I'm not sure what you mean, Christ. 181. No, that's correct. Because the function is likely die, true or false. True, I likely die in this state. If I am dead, then I am likely dying. Oh, yeah, that's what you meant. Oh, yeah. Yeah, blah. I understand now, thanks. So now I prune anything where I likely died. Any intermediate step, and I have to remember that if at any intermediate step I die, I now prune that out of the tree. And yeah. Now I hit the exact problem that I won't place a bomb, because the moment I place a bomb, I've probably died. And so likely die now says... And entity dot param, what's the countdown one? Param 1. If it's going to die, it's going to be 0. Wow. This is going to be tricky. We're going to need a lot of look ahead just to avoid those bombs. Now, what did I do wrong again now this time? Less than or equal to 1? I moved out of the way of a bomb. I bombed stuff. Look at that. I actually bombed stuff. And I think I'm accidentally picking up items, and so I'm not considering the bombing anymore. Right? That's the issue there. I actually have to consider how far the bombs go. Okay. But I did stuff. That's an improvement. And bomb here has to actually be an entity. Entity, because the bomb range is bomb.param2. Bomb.position. Is entity within range? Boxes within bomb range. Bomb is going to have to be an entity. This is a bomb. Boxes within range. Now, what was it called? Boxes within bomb range. Boxes within bomb range. It's going to have to be the bomb. It'll have to be the bomb. I guess I don't need this anymore. I think we're pretty sure that's working. This is 186, and it's also a bomb. And 291. Bomb not position. Alright, let's see if we do any better. I have to remember that Silver League, we're already at 104, and our strategy is to sit in the corner and drop one bomb. So even if we fail here, he's like, my guy's really nervous. He likes to cut it close, yeah? It's like, what do we want to do? Let's just play dangerous here. I'm guessing we die by the opponent here. Like, look at the bomb range. You know how far you're going to have to search into the future to avoid these bombs? We're actually doing quite well. I'm curious as to how we die. We don't place any more bombs. We don't die. Yeah, and this is the thing I feared about. Because we don't have any heuristics involved, my search depth isn't far enough to get us somewhere where we might drop a bomb. So we actually lose by points, which means we might be good enough to submit this and see what happens. So we're going to submit this and see what happens. Some of them win really fast because the guys die. We understand that. Most of them are going to... Anything at the bottom we're going to win. Oh, I forgot about multiple players. We probably do horribly there. I don't think I saw his bomb. That's a problem. I think I missed that guy's bomb in that one. Chain reaction. Yeah, I don't... It's a 2-2. We don't have chain reactions. But I really just think I didn't see his bomb somehow. That's weird. And... Now, I definitely don't handle chain reactions, but I don't think that's what happened there. But okay, let's see this one here. Well, I won this one. It looks like we're scoring quite well, though. I wonder if this is good enough to get out of Silver League? Maybe. I don't know. We'll find out. Okay. Yeah. If you're correct, if it was a chain reaction, then definitely we don't handle it. And this situation here is one we also don't handle. We're stuck because we don't search far enough. I may have blocked the bomb, and I don't check the blocks, but let's see where we do with this, because we're going to see how much we have to improve our algorithm to get further. This is the one we're going to have to do, and this is the one we're going to put the heuristic. And we're going to value scores higher, positions higher that get us closer to like a desired position. And so there we might use our old algorithm, the old one that says, we'll find a bomb position that's good, and if all the scores are equal, let's go where it's put a higher value towards them. So this is an interesting matchup. Those ones are doing nothing. Oh, but we're not climbing fast enough, so it looks like the other algorithms are good enough. Right? And this is another situation where we get stuck because I'm unwilling to place a bomb because my algorithm doesn't make us look far enough ahead to actually get out of the range of that bomb. And we know we can improve that. We know we can improve that with an A star on the actual bombs, that basically anytime there's a bomb, we can actually do a little A star and figure out, could we actually run far enough away from this if we had to? And we don't do that now, and I don't know if we have to do that in this round, because even here, if we get stuck on this round like this one, we can still win these things. So we're going to have to look at some more where we lose. Let's look at this one, what happens here. We place the bomb, we're the blue guy. And find out how we die. I think we just don't get enough points. I don't know what your algorithm is, Cries, but I have lots of places, little algorithms we can stick in place. Oh yeah, we don't want that yet. I don't need that yet. I don't think my position where I walk around like an idiot is the problem. I think it's probably dying that is the problem. This one we lose from points, which I don't think is a big deal. We're going to lose some from points. Right. I don't care if we lose from points right now. I just want to look for ones where we lose from dying. Let's look for ones where we lose from dying. Dying. This one. How do we die in this one? Evening Rush timeout. Well, that's not a good one. That's a good way to lose. It's a timeout. I don't know if we can compare yet. I think we have to be in the same league, but I can check. So this one we just finished. I think I just don't have enough points. So maybe getting stuck is the problem. Maybe I actually have to need something better. Let's go back to players. What's your name on here? Is it also Cries? If it's also Cries, it's... Well, no, we can see other ones. I don't know if I can see people in gold. I can see people behind me. No, we can't get to somebody in gold. But you can compete against us. It looks like. You might be able to compete against us. Because it looks like I see silver and below. Alright, but let's go back to the leader. Well, this is kind of bad. We're not doing any better than our stupid algorithm. We are slowly going up, but... Let's check some more what we lost, because I think I know how to fix this relatively quickly, but it's going to cost us a timeout to do it. So here's another one. How do we lose this one? We're the blue guy. We die. That's bad. Let's figure out why we die here. How do we die? Oh, well, yeah, we're not searching far enough. I can see how we kill that one there. Okay, so... I know what we can do. It's a little bit of work to do it, but I think we have to do it. And we're going to take these ones over here. And we're going to lock this into manual place here. What we're going to do is from the bombs, I'm thinking in my head how we do this, but I'll pause it at the point when I'll explain the situation. Right here is where we died. We placed the bomb and walked in this dead end, and there's no way out of this situation. And because we should have not walked into there, and we can identify this, what I can do is I can flood fill the map at any given position. We're going to do this. We're going to try this. At any given time, in any given position, I'm going to flood fill the map, and I'm going to have a safety score on every position of the board. And the safety score is going to be how many turns you need to get from that position to a safe spot, where the lowest score is 0. 0 says it's a safe spot. So this position here, this is going to be an infinite value. You cannot get to a safe spot. Whereas this value here, if this bomb is going to say, well, it's going to be 1, 2, 3, 4. So this value is going to be 4 here, saying it'll take you 4 turns to get to a safe spot. This one's going to be 3, 1, 2, 3, or just 2, 1, 2. And we're going to count all of these, and when we walk around, we're going to decide, look, when we have a decision to move, and this I think is better than the quasi-logic, because we're going to take the bombs and say for all the things, where's the next safe spot? Now I'm just trying to think of an efficient way to do this flood filling algorithm. Alright, I know how to do it. We can start from the bombs. We can start by marking all of the squares as safe, and then seed the bombs. So we mark all the spots as safe, and we seed the bombs in. And then from the bomb, we mark the bomb as the range of the bomb, so 3. And then it'll go 2, 2, and it'll go 1, 1, 1. And as soon as it hits a space that is actually safe, it will mark it in these directions. So 3, 2, 1, 3, 2, 1, 3, 2, 1. And it'll only mark those ones. And, oh wait, but that won't. And then how do we convert that back? Now we have to know if there is a safe space from there. Damn it. So given any move, how do we find there's a safe space? Do an A-star, but I don't want to do an A-star in every single evaluation of a move. It's the is-likely-die function actually has to do it. The is-likely-die has to say, is there a safe spot to go to? Oh man, this is hard to think about, and we already have timeouts, so it's going to be an issue. We do climb the ranks, but it is going to be an issue with those timeouts that we can't do too much there. But I don't see how else we could do that. I'm just thinking aloud again. It has to be something like that. When we put a bomb down, we have to decide whether the spot is open or not. And where is a safe spot? Trying how do we do the algorithm? We have a safe spot. We know this is safe here. We know that's safe there. There's nothing safe here. If we went far enough, it's a safe spot. Yeah, cries, that's what I'm trying to think of doing at that time. Well, it's not just a matter of killing me at a certain point in time. I actually have to avoid making the move right in the future, because right here, on the turn I decided to move here, I wasn't dead yet. We have to like temporarily backtrack and say something. I'm trying to think about exactly how to do that. Because when I decided to move here, I wasn't dead yet. This bomb still has a countdown of 8. This spot looks safe based on the current algorithm. So it is just a time thing, but we have to somehow mark saying, look, there's no way out of here. And so sometime we have to backtrack and say, this move is unsafe. Also based on the distance. That's why I say I'm looking for a way to distance to safety. How many moves required to get to safety? That's why I was saying here, the moves to safety are 4. There's 4 moves to safety in this dangerous area. And so maybe I should do that. We calculate the moves to safety first. And if the move to safety is greater than the bomb value, yeah, okay, that's how I do the flood fill. I get it. I'm trying to do 2 flood fills at once, and no, shit, I got it wrong again. Think. I'm trying to think of 2 steps in my head, and I can't quite do it. I'm trying to combine 2, so I have to have both know where the range of this is and the range to safety here. How do I do that filling? The basic question is, can I get to safety from any position before the bomb goes off? And I want to make it cheap. Maybe I should avoid doing a flood fill and actually literally just do a simple A star in each one. So if I evaluate a position here, I can say, is this position safe? And I have this is likely die function. And it actually checks either there's no bomb within range. If there's no bomb within range, it's safe. If there is a bomb within range, then we count, well, where is the next safe position? We do the A star there to figure out, can I walk to a safe position with the period of time? And if I can, then I say it's safe. And if I can't, I don't say it's safe. But, did I not do that already? And so this is likely die function. Is the likely die function is the issue. Likely die, if I'm within the bomb range, I have to decide can I walk out of that range safely? And can I do that efficiently? Because this is evaluated every time. Wow, that's rough. And well, I don't need to have an A star here. We can work based on the bomb mechanics. The bomb only shoots in 1 or 2 directions. We can simply scan through and check for moves ahead of it. We can scan for this a little bit better and just decide which direction we have to go based on the current position we are and the direction to the bomb. Can we get away from this bomb in time? And so the first one we're going to say, though, here is if entity.position equals player.position, we can just skip this one. The reason we're skipping this one is because we just placed the bomb. Just placed, so skip safety check. can change it after. I just want to confirm my thought first of all, whether it works. Because I think that's the reason I'm dying most of all, is not the chain reactions, is this one. And I don't have to consider, because basically what I'm going to do is I'm going to say, I think this will work logically because I can't walk within range. If the chain reaction is within range, I'm going to die from this bomb as well. So I think I'll be okay with that. So now we need a function called can walk safely away. State and state. And what position do I have from I point to? And bomb. Entity and entity. This is a bool. Why do we return true here? Is entity bomb within range? Wait a second. Okay, that's we're checking this one here. Duh, we're going to take away this check. That's why I was doing it. We're going to take away this check. It's a bomb. Can we walk away from the bomb? Okay. And we know we're not on the bomb, so we should be okay. So we have a position towards the bomb that we can actually walk in. And we'll just start iterating over them. And we know that each phase, we can check each position we want to walk in. As it's so simple in my mind how to do this algorithm, but now it's just like a matter of we have a certain number of steps to go. And if we can ever leave the path of the bomb, we're safe. Or if we walk far enough away. All right. Well, first off, we can do is entity within range. We're going to see how many steps we can walk away. How far away are we from it? Let diff equal from dot position minus bomb dot position. If diff.x does not equal 0 and diff.y does not equal 0. Now we don't have to check this because we already checked is the entity within the bomb range. So we know it's within range. Now we just have to decide can we actually walk away from it. So so one of these is going to have to be 0. Now we're going to say for I in 0 dot dot, how many steps do we have? Bomb dot parameter 1. No, 2. 1 was the countdown, wasn't it? I hate these things. Bomb to parameter 1 within the countdown. We have that many steps. And at the end, we're going to return false. If we don't have it in that time of false, we can't walk away. So now I need the orthogonal basis. Let's check all the positions we are that are not in the range of the bomb. Thinking. I was thinking slowly today. Sorry about that. So I want to walk away from the bomb. And if there's a space off to the side, this is what's really annoying with basic vector stuff. You can very logically think I have a line I want to the side, but it's very hard to do with this diff thing. Well, I know how we can do it. We can do it this way. Where is the point class? We have direction to. So the diff is, we need the direction to is now. The diff is, let's do this. Direction to from position. Okay, so this is the direction. And the norm is going to be, this is going to be really weird now. We're going to do I point to at direction.y, direction.x. And this is the normal to that direction. And it's one of the normal. Technically, it should be, I think, minus d by x, just to keep it in line with floating point normals. But it won't make a difference here, and that should be fine. And so we're going to check the two spots. We're going to check n1 equals from plus norm. And we're actually going to say let current equal from, and this is going to be mutable. We're going to update this. N plus 1, and we're going to say if state state.grid.get n1, get default n1 cell type wall. And how do we want to say this? It's safe. How do we say it's safe? Do we have some safety checks so far? Something that says item or is valid move. We have is valid move. Is valid move. That's what we want. If is valid move, oh man, we pass it the state and n1, then we can return true, because we know this is outside of the range of the bomb. And so we can do the same thing here. n2 equals from minus norm, this goes the other direction. If is valid move, state comma n2, then we return true, because that's also a valid position. Otherwise, we check now is in our current position. In our current position, I might be off by 1 here. So these are all going to take 1 move. And so then current equals current plus direction. We're walking away from the bomb. If this is not a valid move, then we're screwed. This means you're trapped. Then you return false. Otherwise, we return the diff. And I think we have a Manhattan distance here, Manhattan distance. If current dot Manhattan distance to the bomb dot position is greater than the bomb dot param 2, then we're safe. So these are all the conditions we're safe. We're walking away from the bomb. Can we walk off to the side of the bomb, or can we walk far enough away? If that's the case, then we can walk softly away. And so we say if we're bomb within range, you can walk safely away. State. And we shouldn't need and state here because it's already a reference state. And from, we're in the player dot position, and we have a bomb. Alright. 184. Entity dot position equals player position not found in the scope, and bomb dot position. 195. From is just from. Alright, I'm in manual mode, but I'm going to press replay anyways. I just want to see, make sure he doesn't make that dumb move right there. Now we got further, which means we probably didn't make the dumb move. We didn't die first. So we're the blue guy up there. And we don't place any bombs again. And we're going to have to write a test case for some of this. We don't place any bombs, most likely because we can't walk far enough away. But that means my algorithm is a little bit screwed. That it should have detected if I place a bomb like here, I can walk over there and that's safely away from it. So I'm guessing we're getting all negative scores here. Pause. Negative, negative, negative. So any place we place a bomb, we're getting a negative, so we don't do that. And that's because the algorithm must be doing something wrong. Let's do one more quick debug test before I actually go into the actual testing mode. Player's not alive, that's fine. If we likely die because we cannot walk away safely from state, player position, and bomb. If the bomb is in our position, that's fine. We know we can walk away from it. And actually, we don't even need that one. If we can't place a bomb safely, we shouldn't. So we just say that if the bomb is within range, can walk away safely. And how do we do a positioning? We do end from, aha, because we're doing from here. This should be current. That was the issue here, current. And that we can walk away from. Let's do this. 4-player ones take a long time to evaluate because all the players have to be evaluated. And they're allowed to take 100 milliseconds. And we still don't place a bomb. So we're still being something wrong here. Right? So either we go into debugging mode, or I just quickly logically think, one more time, can I actually do this? Bomb param 1. We're going to actually have to test this thing, I think. Alright, fine, we do tests. And this is probably why I made this public. I don't know if we can make friendship functions in Rust. I don't really want this to be public. I want it to be public for testing. I don't know if that's possible. Can walk safely away. Now what I'd really like to have a function that parses a state from a text input. And I think we partially had that with entry here. We had the characters here, enumerate X, Y, and a wall, 1, 2, and whatever this was, 0, 1, 2, X, and something else. Okay, cries, I mean, that is one option, but how do you do that when using the test subdirectory? Like, my tests are in a different directory. Can I still make them a submodule of it? Because the recommended setup is to have this test directory, and that's not part of source. Can I still make a file a submodule of something inside source? It's only for integration tests. Okay. Well, I'm not sure how I put the tests in there then, but I won't worry about it for now, but I'd like to know that because well, it's going to have to be an integration test though. Because any module I put inside here is going to be limited to the stuff inside here, no? I know they can be transit. They can still reference state and stuff. Strategy kind of feels like integration test anyway, so I won't worry about it. I'll figure out how to do that later. There's probably some way to do what I want. I'm used to using things like internal or friend or something like that, but there must be some way I can do that. And I won't worry about that now. So, can walk away safely. Can I quickly get a grid into the system? Now, actually, maybe I shouldn't use the entity loading I have from the main game loop, because for testing, they're very much likely want to put different things into the test loading. So let's actually do something else. Let's make a different test thing. And, all right, so how do we do that? So I can have a test module at the top of your crate and then have the functions as pub crate. Aha, so that is like an internal visibles too. Let's get this working first just the way it is, and oh, if that's new it might not work. But that sounds like a good option. That sounds very much like what friend would do, or internals visible too. It basically says something else. You can use this. But let's move on to this. So I want to make a helper function first of all. The helper function I want in state is an option to parse a state, parse test state. And let's see how we can do this. We're going to have a function called parse state. And we'll just put this on state itself. Public function parse. This is a string. Is it a string or a string? I don't remember what this is. Okay, so what we have to do is, how do we split data into lines? Or line in data.lines? Can I hope for that? For C in line.chars. Let mut x equals 0, let mut y equals 0, y plus equals 1, x equals 0, x plus equals 1, match C, and we're going to clear the entities. This is actually supposed to be and mut self.entities.clear. We have to clear the entities because otherwise the board can be in inconsistent states. Trim. And so we say if we have a dot, this just becomes empty. we'll do self.grid.set. It did show up, didn't it? I see. I'm not sure what you meant, but I did see your /r thing in there. Oh, really? You can't type /n. Lame. Lame. Well, it works like that. I was curious. /r/n. Lame. Alright, but if I type just a /n, it goes away. But a / oh, I don't know. This is weird. I don't know. At x comma y, cell type. Well, you said the \n did not show up. I was just testing \n. Cell type wall. And actually, we should do this. Let position equal. Don't like any kind of duplication. Duplication's bad. I hope this is a safe image. What? Did you not see anything I wrote? Do you see what I wrote just now? What? I'm going to reload that window. It's crazy. Now do you see something? Apparently you can have some sort of split. But do you guys see what I wrote now? This? Anything? Oh, so, Andor, you're seeing my stuff. So, Andor, you can confirm I'm seeing my stuff. Oh, weird. We've had... Twitch is weird. Twitch chat was weird. Sorry, guys. I mean, I don't know what the problem is. Bye-bye. It's okay. That's, I've had that problem before, though. People have not seen me, and it looks like you don't see me. There's this... Twitch chat, it looks like you can actually get disconnected. I have no idea how you check that, though. Alright, so let me finish loading the stuff in. I think this is all we need to do tests so far. Let's do this. Now we just won't type anything in chat so you can never tell. There you go. I smiled. (10,5). So our test setup's getting a little bit weird. Cell type empty. We have to fill it at least once. And I'm gonna fix that because that's gonna break us at one point. New, we're gonna say let s equals new, let mutable s. Return s and then say s.grid.fill. Oh, where's the fill function? We'll just do a sanity check there. then I can remove these states things here. So now we want to do a state.read. And hope string concatenation works. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the one case where I'd like to have a monospace font. Can I just quickly switch to one? View. My other editors have it. I want to quickly switch to a monospace font. Just for this grid-like thing. Well, I'll figure it out. Because otherwise it doesn't help me test this thing. I was hoping to get a little text in here. I have to have 5 lines. Does the plus work in Rust? Can I do pluses like that? edump. Let's put some walls in. We're going to make every second one a wall. So now this is the one few cases where I'd like to actually have a... How can I concatenate strings quickly? And I'm just going to make this 3 long. That should be enough. So can I just do this? Or do I have to leave off the string? I just want a bit of template. This is getting really hard to write here. I was hoping it'd be easier here. Will that work? We'll find out. Cargo test can walk safely away. $124 match C. Guess there's no that there. Okay, I think I see what you mean, Kraz. It's just, okay, I will be fine with this. Pattern not covered, that's fine. Just go away. Actually, no panic. Broken test. Well, I want the line feed in there. State.read. Parse. Parse. I call it parse, which makes more sense. Ah, this stuff again. I hate strings in Rust. I'm going to say it again. I hate them. It's hard to work with strings. I got that, but I actually want the line feed in this case. What am I supposed to take here that this can be a string? It's like an and stir or something like that. Alright. Okay. Failed. Where did it fail? Alright, rust backtrace equals 1. It's on the wrong part. Rust backtrace equals 1. Where is it failing? It's failing in find play. Oh, I should probably add a player to the game. Probably add a player. Yeah, Enduri, this is what I want. I specifically, that's what I thought. I suspected this would preserve line spaces, and this one doesn't, and I actually want to keep the line feeds in, so I'm not using the slashes here. What's it panicking about now? Find player. Why is find player getting upset? State 42. Dump 95. Well, it should have found the player. State add entity type 6 player myID 6. And well, he's not in the right place though, so let's stick him over 4 at 4, 1. How is fine playing one that's fair? Why is fine player failing? Print line player ID what am I looking for? Six. He's looking for 6. Why is it not found? Because parse clears the entities. Alright, so we're going to have to make parse not clear the entities. Or we do it afterwards. That's the correct thing. We do it afterwards, before we dump. And -- no capture. We want to see what comes out. We want to see if we're actually parsing that correctly. Oh, of course not. What's the problem now? So passing no capture made it fail. What? So we have a problem with the flags. Unrecognized option, no capture. What was it called? Come on, I updated this code. Stupid thing. There's no dash and dash capture. Alright, so we have that. That looks like the player's in the right place. But I want to place them at 3, 1. And the key thing we have now is we want to say... Well, let's make them more X's on this side. So one place he can walk away, the other place he can't. And so state we want to do strategy. We have a can walk safely away. What's the signature of this? Can walk safely away. Assert equals true. Can walk safely away from and state. And where are we at? We're at I point at 3, 1. We're at 3, 1, and we need a bomb entity here. We can probably just add another entity. Add entity. New entity type. Bomb. We could even make it this owner. I.2 is at 4, 1. And param1 is when it's going to explode. We have 2 turns to walk away, so if it explodes in 2 turns, we should be okay. And it has a range of 3. And we have state.entities 1. Unclosed delimiter, that's correct. Whoa. I.2. Oh yeah, that has to be strategy. Reference. And so what we're checking now is that our can safely walk away. We suspect it's not working. We want to figure, oh, it can. That one can walk away safely. Right, but if we're on the other side, we don't suspect, we shouldn't be able to walk away safely on the other side of it. If we're at 5, 1 on the other side of the bomb, then we can't walk away safely. That's correct. So, what part of this is not working? Great. So we can walk away safely. That works, and... just to test, if this bomb had 1 less, the first one would fail. Yeah, that's correct. So, walking away safely, should we test one that's vertical as well? Let's call this one horizontal. Let's just check one that's vertical just to be safe. And this is going to get a bit trickier now. Dot. Go away, you stupid pop-up. Dot x. X dot x. Dot x. X dot x. Dot x. X 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 dot x. Okay, and this is 3, 10. We're just going to transpose all this stuff here and make sure it works. 1, 3, 1, 4, 1, 3, 1, 4. No, this should be 5. This should have been 5 here as well. Can't walk away from that. Oops, this should be vert. Okay. All right. So we have reasonably good evidence that can walk away works. Can walk safely away. So now we check is likely to die. Is likely to die is the next one that should work. And we have that just in this test here. Is likely to die here. Should be false. Assert equals false. Strategy is likely to die and state. And that's going to have to be public now just for the sake of that function. This is an avert 1. Not found in strategy. Oh, it's just likely to die. Likely die. I don't know why I put that one. Yukakun, yeah, we're very welcoming. You're allowed to ask whatever question you want. I can't promise I can answer it, and I can't promise I don't give a snide remark about Rust. Not about the question, but about Rust. But feel free, ask away. Alright, so right now we're just working on some test cases for our strategy for our bot. And it's pointed towards working correctly, which is kind of a pain in the ass. So let's put this player here at 1,5. And then he is likely to die. True, he is likely to die. This is vert. Can I get rid of that part and just run all of them? Can I run star? Is there a star option? Ah, there is. I think. You can't tell. This thing produces so much output. No, 0 tests ran. 0 tests. Is there any way to run like a star of tests without getting every single directory? It doesn't look like it accepts filtering, but in any case, I ran vert. Horizontal. Can walk safely away, whores. Aha, so something did fail. 61. '61 was supposed to be a success. Let's check if it's an off by 1 error. So Yukako, and like I said, you can ask a question. I was assuming you had a question. So 4. Okay, got that one. So Yukakan's asking, he bought the book, Rust Programming is Helpful, and... Oh, can I recommend papers? You know, I've just been using the reference guide and the online guide. They have an online book, and I've just been referencing that randomly and looking up random things as I need them. So, other than that, I don't have any other book. I just, like, the book on their website, I learned some things from that. Though I must say their book itself is not actually very good. It doesn't cover actual use cases. It covers a whole bunch of theoretical stuff without getting into use cases. So mainly I've been looking at random code online and various other places. It's a bit hard to get into some of it. So unfortunately, if you have a good book, I don't have another one for you. Alright, so this one's failing, and we have to figure out why it's failing. So is likely to die is false, and for whatever reason, is likely to die is returning. The player's not alive. Let's just verify this one again. Can walk safely away horizontal. This is the one that's failing, just to make sure. Okay. So ePrint line, is it alive? Are we alive? Player.alive. I hope he's alive. Alive is true. So what parameters are we passing to here? Walk, player.position, and let's do the bomb ID, player.position, or bomb.position. We just print out the whole bomb, probably, to make sure it's the right bomb. I have a feeling we're not passing the right bomb in. 3,1, owner 6. Let's check to make sure that's correct. So add entity 6. It's a bomb. It's a 4,1. Parameter 2 and 3. Alive is true. I.2 is at 3 and 1. So that appears to be the exact same. Alright, let's look at the question again. Sidetrack this question. So edA-qa wants to program 2 games run, but GUI libraries and game frameworks seem to be still in early development. Pistons, are there other libs promising? I'll let Cries or somebody else answer that. I know nothing about UI programming in Rust. If you saw earlier today, my UI program I'll be doing in my own language, Leaf. And so earlier in the day I had Leaf stuff. Right, as a distraction. This is how far we are in our Leaf GUI framework. And this is another language though. This is my own compiler. And this is from earlier in the day. We were fighting with some GL. And it also has no framework, but it doesn't have a standard library or anything. I'll be working again on this tomorrow morning. But isn't it pretty? This is like 3D accelerated. You know, this is like super fast. The reason why I'm doing this in Leaf, and I'm going to do it the same for once I get this more, is I'm going to actually do these algorithms behind the Bomberman right now, the Hypersonic. If you're looking at the code watching this show, it can be pretty hard to figure out what the hell I'm doing. And so what I'm going to do with Leaf is I'm going to come back, and once I have this basic graphic stuff working, I'm going to program these algorithms in Leaf, and then I can show you side by side what are these algorithms actually doing. How do they figure out where the bombs are, what they're tracking, and stuff like that. But this is now, and this is the baseline Tron work, because the reason I'm doing this one is I want to show how our Tron algorithm works, and we're going to get back to that at some point. But that's a nice distraction for that. Let's go back to the Rust stuff and figure out why likely day is failing. So can walk away safely is true with these values, but likely die is true. But all it does is pass what the hell? Oh, so this should actually be if can walk us. This is the opposite. If we can't walk away safely, then we return true. Aha, so it's the opposite. We have the opposite way. That should be pretty good then. Now it should succeed. Now it succeeds! Yay! Aha, cargo build. So now maybe we're working. Let's go back to our graphics. Let's submit this thing and let's see if this works. Let's see if we place a bomb at some point. I don't know why that thing's updating like crazy over here. Something's gone wrong. Uh-oh. Stop it! Stop reloading! Stop it! So I think that was the importer gone crazy somehow. And we got a partial file sent up. So we place a bomb now. That looks good. We place another bomb. We're the blue guy up in the corner. We place yet another bomb. And we don't walk away. Well, that's pretty stupid. Why do we not walk away? Let's figure out why we don't walk away. We used to walk away. It all gives us 13. 12, 1 is 13. 12, 1 should have had a higher score though, because it's not within the range of a bomb. So that's one failure there. And alright, something's wrong with the bomb check here. We have the bomb, it should have killed us. And it's only given us the one option, so it's already trimmed off the other options. So it's actually making a decent decision then. 12, 0. Oh, and it's because of back here, we don't search far enough, so we didn't actually realize that we should be walking away from the bomb. So now we're going to check anything that puts us further away from a bomb should be better. Damn it. And this is all to make up for the fact that I can't search far enough down in the tree. If I could just do a search deep enough in the tree, I wouldn't have to have any of this heuristics logic, because it would simply know, hey, get away from the bomb. And these is likely to die functions we should be able to test. But this should have known right here. At this point right here, it should have known it would have died. Because moving to this position, there's debug settings here. Debug mode on. 3, 2, 1, 0. You know, maybe my timer's off. Maybe my timer's off by 1. Can walk away safely. edA-qa, I do kind of have to agree. The macros are kind of annoying. They have some advantages. They have some disadvantages. What they do have the advantage of the macros, and I can compare this to C and C++, is the macros are a proper part of the language, which is a massive plus. Definitely a massive plus that macros are a proper part of the language, whereas in C and C++, there's some of this bastard pre-processing thing, which makes them really hard to work with, but extremely powerful. Now, the Rust macros are not nearly as powerful, but they're easier to use and less prone to error, but they are kind of bulky and annoying. Alright, let's see if I don't die now. I survived longer this time. And look, I actually walked away. That's good. So I'm not being totally stupid here. My bot does something halfway interesting. And he avoided walking in that hole. That was what we tried to fix. He avoided walking in that hole. That's good. So how does he die now? Probably from an enemy bomb. Probably gets trapped from the enemy because we don't know what else to do. He's also placing bombs in the wrong spot. That's weird. I got the range wrong again. What the hell happened there? Whoa, 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 whoa. Why'd I die? Did I time out? I timed out! That's why I died! No fair. Well, let's figure out anyways. Let's just submit it and see how well we do. Because we think we're doing better. We lost all the first battles. Oh yeah, this could be a problem. Our timeout could mean we lose battles pretty fast if it's not enough. The board's not congested enough. We'll find out though, I guess. We're going to see why we die. If we're going to keep timing out, then we have an issue. Yeah, we just timed out. That one just timed out. Crap. Crap, crap, crappy crap, crapola crap. I was hoping I wouldn't have to optimize yet. Maybe I changed the search depth even lower, which makes our heuristics even more important. Which is kind of scary. Oh, but we're still climbing, so maybe we do alright. Timeout! Damn it! Timeout! We're still climbing though, so maybe we'll do okay with the timeouts. Yeah, we are still doing okay with the timeouts, so we're still winning enough battles that we should be climbing up. And this is the one we know we get stuck in. And it's sad that we win this. And we get stuck because our depth isn't far enough to get us somewhere useful. Our depth is basically saying, yeah, let's go to the next game. So we're going to have to put a heuristic there too. But we're showing progress that the basic approach we have might actually work. Alright, and there we got ourselves stuck in the corner. That's one we know we can't deal with there. We actually killed both of us. There was... And... Is timeout while we're losing? Let's find out this time. Is timeout, or are we just not doing a proper position here? Why do I lose this one? I time out, I bet. Because the board's too open and I end up timing out. Oh, I do win. Thanks, Cries. I was wondering why I lost this one. We are climbing slightly. Not so fast, but we are climbing slightly. Let's see one where we lose. Why do we lose this one? We are red, and we time out. Oh, wonderful. So this one. Second, we don't have enough points. Interesting. Yeah. And this is our depth searching right here. We don't go far enough to realize where do we place the next bomb. And we knew we'd hit this. We knew we'd hit this, so we go back and forth. Just because it doesn't know what to do. And let's see if there's any minor preference we can do for this. So we set that up, and then where do we get into this loop? Now we're into this loop. Now we do one more. Then we go into this loop. And why do we go into this loop? Because we don't go far enough to evaluate. Because we never place a bomb anywhere. So we have to modify the score ever so slightly to choose a position that is more valuable. And so all of these positions are worth nothing. I'm not clear why it picks one over the other. Oh, probably because it picks right and then left. Cries, in this case it might work, but I can't rely on score 0 because we might have a different score. And actually, I noticed I'm not considering the score at all, which is bad. That's really weird. Why don't I consider the score? But if they're all equal, is the one. If they're all equal, I should consider something else. But it doesn't change the fact that I could just be one or off, and back and forth I might have the same thing. And how can I go to the nearest crate without doing an even worse search? I can make the state mutable and remember where I was before. I could favor paths that move us the furthest away. That's an option. Let's try that one quickly. That's an easy thing to change. What I can do is I can slightly favor a path that moves us furthest away from where we are right now to avoid us getting stuck in a little box. Oh, but wait, that's just going to evaluate the path And they're still going to have all equal value. Let's see if we can increase the scoring in some cheap ways to do it. Instead of them all being equals, you notice I have the score here, and this bothers me that the score, we're not inputting the score correctly. It should have all been 40. Does the game actually give me the score? It does not. You know what, Cries? It doesn't matter because it's going to be the base for all of them, so let's ignore that point there. I was just thinking that I obviously use the score when evaluating the routes if I do something, but the base score I enter the round with is completely irrelevant. Okay, so good question, Yuka-kun. Why does this have to be a slice? And I don't know. I just don't know. Please, somebody answer this question. Oh, but it does, Crisis. We don't know how else to do it. If I take away this slice, it doesn't work. Like, if I take this off, it'll whine at me really quickly. See, it says expected slice. Found array of 5 elements. The compiler tends to disagree with you, Cries. It says, no, you can't do it. So you can tell me why that is, and this is why I've been doing slices, because I don't know. Yeah, but I don't want to say the length. I want it to calculate the length. Right? Like, what if I add another one? What if I comment this out? Then I'd have to modify this value up here as well. Is there any way to make this automated? Can I just do like something like this? I don't want to specify the length. That's something the compiler should do for me. Okay, so it's one of those limitations. Yeah, this is... I'll do this, but this is one of the things I disagree with, because this is one of the things, this is something the compiler should do. It knows it's 5. Come on. I mean, I shouldn't have to type 5 there. But now I have the problem that it's not an iterator, it's an array. You know, this is easier to call this a slice and not deal with the other fallout. It's easier to do a slice here than and have the iterator rather than change everything else and make it call iter on it. Slices seem like a nice concept, but there's something not quite missing with arrays. There's some mismatch in arrays and slices and iterators in Rust. There's like a few, like the API is not quite complete, so a lot of little things you think you should do, you can't do. And it makes it hard because I can't think orthogonally. Just because something works in one situation doesn't mean it'll work in another situation. And this is making it a little hard for me to deal with this. The other thing needs an RFC. Well, if I go write the RFC, they're probably going to ignore it. But okay, so we need some scoring. How can we evaluate these positions better? We need... Well, I'll think about it. I'll think about doing that slice syntax. And let's just put a to-do there. If too much time on hands, submit RFC for I point with auto-detected length. Alright, so now back to the scoring. How can we score it without doing further depth? Well, let's let them bomb in more locations. That's one option. Let bomb equal Alright, let's just do this way. We're going to evaluate bombs at all of these as well. So we can start dropping bombs anywhere. But this expands it. We're going to get more timeouts now. Oh no, we just kill ourselves. Well, that's progress. Yeah, no, we took too much time. So we can't afford to evaluate more. That's an issue. No, 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 no. So we can't do this. Too slow. We're just going to consider a bomb at the beginning. For each offset, consider a bomb. And now we need to score it. We need to find the distance to next crate. Alright, so where's our score function? We need a score function, get score. How do we find the closest crate? Super speedy like. Let's pump this score up to 100 and this one up to 10 times. These are the scores for values, and then we're going to find all the crates within range. Yeah, I do cries, but it's really, really slow, and I'm getting timeouts now. That's why I'm trying to think of something I can do quickly. Like, my Woodley code is unbelievably slow. If I add this in now, I'm going to get a timeout every single time, which is a problem. I have a function called good place to bomb. And it goes through everywhere, calculates the boxes in the range and the Manhattan distance to them, and, well, let's just call it. Let's just try it. Let's just call good place to bomb and hope for the best. Oh, it is. Do you want to know why it is slow? I walked through the state once, and for every position I calculate it. No, but for every position on the board, I calculate the boxes within range. And that boxes within range function goes through every single entity and checks the boxes. I do only call it once, though, so maybe it's acceptable. But now I have to pass it down. Where's my get my best turn? Okay. Good place equals good place to bomb. Where are we? We're at player.position. Halfway, okay, wonderful. Get my best turn. What do we do? Good place, good place, good place. And we're going to pass it a good place. It may not actually have a good place. Good place. Option I.2. And the score is going to take a good place. Another good place. Really? 1 millisecond per round? Why don't you just increase iterations? Oh, you're not doing iterations. You're doing heuristics. That's correct. Score. Good place is an option I.2. Score minus equals player dot position Manhattan distance to good place dot unwrap. If good place dot is some. Yeah, well, your heuristics are still better than what we're doing. Ours has potential, but if we're slow, it doesn't help. But I know I'm super slow, and I know where to optimize a lot of this stuff, so. Oh, well. We're going to check why this isn't working now. Hey, we walk somewhere else, though. That's a positive thing. We do walk somewhere else. Do we just not get enough points now? That's what it looks like. I'd be willing to accept the loss where we just don't get enough points, but we get stuck here again. Stuck is... And he gets stuck too, though. Now, this is what I'm scared about the score. No more bomb. This has to work. We have to be able to get to these stuck positions here. And so what's happening is we probably have alternating scores. -3, -5, -2. And we chose to go to 12,9. Because there was 2 at the same score. And next round we have a whole bunch at the same score again. How can we have a whole bunch at the same score? You know what we should do is we should track the last place where we dropped the bomb or the last place we got it, because this, when we're trying to get to the best location, we should probably avoid reevaluating until we drop a bomb. Because if we keep reevaluating every turn, we have this possibility where we're just going to keep flipping. Because it's just going to go from my current position, where's the best place? It'll find a new one, it'll find a new one, it'll find a new one, it'll find a new one. And this is a little bit weird where the strategy is going to come in, and the strategy is going to have a goal. And this is something we did in the Borders of the Galaxy where I screwed up. I didn't allow strategies to have goals, and this time I'm going to. I'm going to allow them to have a goal. And that's how we're going to modify it right now. Let's give them a goal. Let's submit this, though, and see what happens, just for the hell of it. And by a goal, I mean is that our strategies... I just checked. Yeah, okay. edA-qa and I know nothing about that. Is it really not self-producing? That's weird. Okay. So what I mean by goal is that the strategy now is going to be allowed to... It's going to be allowed to maintain its state. So the strategies are not going to be immutable anymore. So how do we do that? We have a strategy, and we either put it on the state, How do I store the strategy? I need to store a goal. Where do I store the goal? It should be part of the strategy, but I don't have a strategy object yet. So let's just create one of those things. Struct. Just call it strategy just for now. Why not? And it has a good place. Well, edA-qa, and if that's your opinion, then you'll love my language Leaf, because it doesn't run on Windows at all right now. And this is allowed to have a default. Copy, clone, whatever the hell it needs, debug. Public function. And it's going to have two things, two functions, one called step, and it's going to take the current state, and that's going to do nothing for now. That's fine. And public function is it's going to take a apply turn if it wants, and state turn. Okay, and the reason it's doing this is because it needs to have a goal function. And this means also when we say get best move, get best, it's going to take a state, and it's going to take a strategy. Now this is going to be a mutable strategy. The reason this is going to be a mutable strategy is because my best turn is now going to be able to make goals. And this is something important to remember when testing this stuff. Now you can make goals, and everything's going to fail now when I do this, but that's okay. get my best turn, and entry is going to have let which strategy equals strategy. I'm just going to say new instead of default. Function new self default. Okay. Oh, sorry. Okay. And so when we take a state, what do we call step? Strategy.step, that's state. We're going to give it the state. Every time we load in the state, we're going to give it a new state. And then right after we apply turn, we're going to do strategy.apply turn and next move. Alright, and so we're going to do a couple things. We're going to say if, well, we're going to get the player first of all. Player equals find player. We'll just do it here, state.myid. If player.position, actually no, we can just do this. If good place is none, then we can just return. There's nothing to do here. Otherwise, if player.position equals good place dot unwrap, then good place equals none. We're going to clear it up. If turn.bomb, we're also going to clear it out. If we place the bomb, then we're going to clear out the good spot. Or maybe not that. If we place a bomb, then we clear out the good spot. That's fine too. So now we have this good spot here, good place. It's part of the strategy, and now we can make it consistent. So now we can do the get place turn. We can say if strategy.goodplace is none, strategy.goodplace equals good place to bomb, some good place to bomb. So we always have a target that we're going towards. This is already an optional, so we can just do that. And then we can do wherever good place was, we're going to do strategy good place. And this will prevent the flip-flopping, that's the idea. And where's that? I'm going to have to make that public. Public. .22 self. I don't suppose I can convince the Rust community to get rid of this self parameter. I don't like self parameters. I've never liked self parameters. I think it's part of the scoping rules to take care of self parameters. Oops. Player that position 264. And okay, that has to be before the player. Yeah. I do a lot of C++ programming as well, but that's mainly for my compiler now. I've done a lot in the past, and I just love the flexibility and power of C++. Unfortunately, because of backwards compatibility, much of the new features in C++ don't have a very appealing syntax, which is unfortunate. Of course, Rust doesn't have an appealing syntax for some of those features as well, so I mean, that wouldn't stop me from doing that, from using it. All right, step. Oh, it needs a state. It needs a state strategy step. What was the problem before? Oh, I must have misread the the question, the error. Strategy step. I must do a. Oh, this is this thing here. It's an AND state. I mean, this is one of the inconsistencies I don't like either with the self parameter, is that when you're doing it with the self, suddenly the type comes in front of the self as opposed to the other options that comes afterwards. It's an inconsistency. I understand why they did it, because it would be really annoying to do otherwise. I mean, because otherwise you would have something like this and mut self, and that's clearly a shortcut. And you'd want that shortcut, but it is an inconsistency. It's something to remember that it is a special syntax. Get best turn is now and mut strategy. Apply turn. This is supposed to take a state as well. It's supposed to be an and turn, although it may do this. I don't know what the rule of 5 is, edA-qa. It is very easy to use C++ wrong. It's getting better if you do follow the rules. You turn on a lot of warnings and a lot of debug is getting a lot easier, but there's a lot of flags. And I mean, one of the biggest problems C++ has is it doesn't have a good build environment. Every time you start a C++ project, you are immediately faced with, do I want to use crap automake? Do I want to use crap cmake? Do you want to use maybe acceptable scons? It's what package manager I use. So the biggest issue I think with C++ right now is it's hard to set up a project. Not that the language is hard to use, it's just hard to set up a project in C++. Whereas all these new languages, all of them, like even like the Python has been older, Python, Node.js, and Rust, they have. It's really easy to set up a project. You're not fighting with it. It's a lot easier. You're not fighting with a bunch of tools trying to figure out how the hell to create a basic project. And yeah, if you're going to do Rust, make sure you understand move semantics, because it's the basic assignment in Rust. Everything in Rust is moved by default. Alright, let's see what happens here. Oh, I don't think I time out. I don't die. I probably get stuck again. Well, I seem to be doing so good so far. Well, we're doing better. No, 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 don't get stuck there. No, 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 no. Bad, 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 bad. Don't get stuck, you stupid little robot. 6, 10 is -2, and everything else is 0. And then 7, 10, what's the lowest one? 6, 9, 6, 9, bomb true. Six, 9, 6, 9, 6, 10. Let's just submit this again. We did slightly better. We're having a hard time climbing the ranks here. And let's take a look at why. best, and let's put a debug output on strategy.goodplace. We know our current position. Let's just check it out. Trying to figure out why. Oh, it's already 1:15. Oh, wonderful. So let's see where we get stuck. Right there. Okay. 4,8. So I want to get to 4,8. Where is 4,8? 4,8 is right there. And so 6,8 should have been a better score. Okay, that's what you mean, Yukagan. Yeah. This is something, as much as a new user to Rust, including myself, bitches about stuff like this, I actually agree with this from Rust. And I'm going to really think about this for my language as well, is that this derived stuff in Rust approaches that problem in C++, where because of backwards compatibility, you have all this nonsense for declaring a class, and I don't know if they can fix that. They should just introduce a new keyword that removes all of that. And in Rust, what you have is a struct by default has none of that. And that makes it really annoying to use initially, but when you get used to it, it makes a lot of sense. If you want this strategy to copy and clone, you have to explicitly provide it. There's no accidental copy and cloning. And so for this part of Rust, I think this is a strong point. As much as it makes it a little harder to use the language, I think this is definitely a positive thing where you have to explicitly say what you want the structure to support. In Leaf, I have a few different ways to split it up. In Leaf, I have a tuple type, which automatically is a value type. And I have a class type, which is a little bit in between. It's also a value type, but you have to define, you can override certain operators. And then I also have a service type, which has no copy and clone. And it's something I'm going to revisit a lot, because somewhere between what C++ has and Rust has is a good option. And yes. So yeah, that's, I mean, yeah, there's, so somewhere in between these, it's one of these areas you can see people are struggling with in different languages, how to deal with this, and it is something you really do have to deal with. Okay, so now scoring. Scoring, get score, get score, get score. So there's something wrong with this scoring here. I'm at 6,9, and he wants to go to 4,8. One, two, three. 1, 2. It should not have gone there. 6,8 is clearly closer. It should have preferred that. Why did it not prefer that? So what it is, GP, I'm going to say this to this. Score and let MD equal. We have to figure out what this thing is doing wrong. Because it's getting stuck in place. It's the same thing I had a lot. Dealing with scoring, it's really hard to deal with scoring because you always have these little loops. And that's why I have to have this goal. And this goal would help. The goal is the way you break these loops effectively. because you're never going to have heuristics and logic good enough that from a given state to determine what the best move is to not flip-flop. Let's just jump over here a bit. Okay. All right, this is the problem. All right, so the problem is, I keep forgetting about this. We're not evaluating a single move. We're evaluating a search tree, and at the bottom of that, we're checking that. So knowing we can have equivalent scores, why don't we check that at the high level? If there is no score, or there is a score and it's better than it, or the score equals best score, and it's going to be hard. Turn. Oh shit, how do you... I hate these complex ifs. It gets really complicated how you pack these ifs together. And strategy.good place is sum. And best turn dot position, I think. Where is turn? Where did I find turn? Turn. I don't even know where I define turn anymore. Simulator. Simulator has a turn. Position. It was position. Okay. If best turn dot position, Manhattan distance 2. Strategy dot good place dot unwrap is less than. No, is greater than. Is greater than turn dot position dot Manhattan distance. Strategy dot good place dot unwrap. Yeah, Kukan, to be honest, I don't rely on precedence and such things like that. The logic between and equals having different precedents would be silly anyways. And if they do have one, I would assume it's strictly for historical reasons from C, but it seems silly code-wise to rely on them having different precedents because they're the exact same type of operator. Why on earth would they have a different precedence? And now we have a bracket mismatch here somewhere. Yeah, right here. And there's another one here. Best turn dot unwrap. The type of this value. Alright, this is a... Yeah, the type inference in Rust quite often doesn't come out with a turn, as I'm actually unhappy with it. More often than not, I actually don't find I'm able to use the type inferencing other than simple assignments, and even those sometimes fail. Alright, let's see if I get stuck, or I die, or something else happens, or what happens here. We still come in second, which is bad. And we die, though. How do we die now? What do we do? Oh, we die because I get really aggressive with this guy. Why is he not walking away, though? Alright, right there. He places a bomb, and I don't walk away. Why is that? Oh man, this is hard when I can't search. The reason I don't walk away is because I don't search far enough to find a way to walk away. And every path I take actually puts me closer to the danger. Wow, that's a tough one to fix. He got me trapped good here. This really trapped my AI well. Let's try another match there. I think I know how to do it. I'm just going to try another match. The thing I think I'd fix it is in my scoring. Right now I run away from bombs, but I don't think I have to. I'm going to take off this one here. I won't undervalue bombs anymore because that's going to prevent it from walking away. Let's see what happens this time. Well, I still die. Did I rebuild? I don't know if I rebuilt or not. I did. Maybe I should just have my guy stay the hell away from the enemy. Alright, so there is bad, and I gotta figure out why that was bad. I should have been trying to run away, even if it wasn't safe. And it kept saying 4,2. 4,2 is right here. But it's not scoring anything. So the reason it's not scoring anything is because everywhere dies. Everywhere shouldn't die, though. It's likely to die. It looks like it has an error in it. Likely to die has an error in it somehow. Can walk safely away, lock safely away. Player's not dead yet. Oh, you know why? Because can walk safely away does not consider walking towards the bomb. I made the assumption I'm walking to the bomb, but I should actually be walking both ways, away and to from the bomb. So let's split this function up. Can walk safely away. can walk safely away direction. We take a state and state. Take a point 2, and it's going to take a bomb and entity. Do I need that? Yeah. And it's going to take a direction. And that's going to be an I point 2. So what I'm saying is that basically, in this position here, can walk safely away returns false at every one of these positions because it doesn't even consider them. Because it's trying to walk this way and it says I can't walk that way. So it basically says it can't walk safely away. And so it says likely to die, and regardless of what move I test, it says no, you failed. But I also have to attempt walking towards the bomb, because in this case, walking towards the bomb would let me get safely away. Okay, so we put this in here, direction at, direction at. Alright, thanks for watching, edA-qa. I'm almost done here tonight. Tomorrow morning, hopefully I can do some leaf coding again. It'll be early in the morning. I won't be on tomorrow evening, though. I have a lot to do. But I'll be on somewhere in the morning doing the leaf stuff. For those of us wondering, the leaf stuff is going to be keep working on this Wormies game, which is written in leaf. And then we'll eventually explain the Rust stuff. But I'm almost done for tonight with the Rust. Hopefully I can get this basic thing working. I was hoping to get a little higher in the ranks. I'm just getting stuck in loops, and everybody else has better algorithms than me so far. Alright. But thanks for watching, and we'll see you again another time. So now we're going to can walk safely away. We're going to check both directions. Safely away direction. State from bomb direction. Or you know what, I don't have a way to inverse the direction yet, so I'm going to have to do it like this. Minus direction.x minus direction.y. So hopefully he walks away in this one now. I do find a way out of this. Oh, I die quicker. That's really odd. What do I do now? Oh, I time out. Well, that sucks. But I do walk away. See, it's wonderful how I walk away, but then I hit an open area and I time out. Because I do too much calculations. Crap. I can reduce my search depth by 1. But that's going to make me depend even more on our heuristics. But this avoids an exponential explosion. This should cut down the time, actually more than half. This is a good sign. It's taking a long time. We still lose. How? We die. We'll figure out why we die first. If we reduce our search depth far enough, we'll basically just have a heuristic-based algorithm like Cries does have then. So we must get trapped here somehow. So, I mean, we're doing actually reasonably well. And that was a chain reaction, and that's exactly what Christ says before. We're not considering chain reactions. Let's go back to Otto. Let's see if we can win against this guy. Let's see if it wasn't just a lucky play from him. Well, I die again. I'm dying right near the end. And it's probably because as soon as the other player starts getting in my way. See, look, I'm screwed here. I'm screwed there. I get stuck. I couldn't detect the chain reaction enough. And this is going to be an issue. I can't detect the fact that I could have walked here first of all, and then come back here. Just a minute and see where I am. I wonder if I'm just going to have to start optimizing what I do and increasing the search depth. So we won there, that's fine. So their guys aren't moving any. That's probably why we win this one. Do. We got stuck there. Curious. I'm not supposed to get stuck. And here what happens? We died from doing something bad. But we're doing alright. So now we have this... Oh, we're doing a lot better now, if that pattern continues. So now we have this question of, do we have to improve the heuristics, or do we just improve our algorithm to be faster? Because if we can do better search depth, we'll do even better. And our heuristics are also doing reasonably well. But we should be able to search further. And our searching, we know right now, is unbelievably slow how we do it. How are we dying here? I get stuck. Alright, so there's a few cases I get stuck. When I am in a double bomb situation, I get stuck, but we are increasing in the ranks, so maybe we're okay. We can't beat the boss very well, but maybe we do well enough without. This might be a good place to leave it, regardless of what happens, because we're doing well enough. And we saw some places when there's 2 bombs in the screen, we don't get out of that situation, and if we did, we might do a better job. So we're fluctuating now, but we did get higher. And these battles take an extremely long time. Let's see what happens this time. We're this guy up here, and how do we die? We both die at the same time. Alright, so it doesn't look like we're going to climb much more, but it's looking promising for the next time we get back to this, which will probably be next week. The competition starts then too. I don't know if I'm going to do the competition. I don't know if I have time to do it. I'd like to try, but it's a lot of stuff. I have this one. I don't know. I have too much things to do. Too many things to do. Oh, yeah, and that was a chain reaction there. I should have avoided that. The reason I died in that chain reaction was because I placed a bomb in his bomb and didn't realize it's going to explode right away. That was just one of many. We're kind of fluctuating. I don't know how well we'll do here. I think I'm going to call it a night. If you want to look online, you can see it. I don't know if I'll log in tomorrow for Coding Game. I'll be doing Leaf a bit more. Maybe sometime during the week I get a chance. Thursday night maybe it's the next time I'd probably be able to do Evening Rust. Unless I'm bored on Wednesday. We might still climb the ladder a little bit here. And so the next step will be improve heuristics or improve performance, because we can't go depth, or depth is too slow, and we know our performance searching right now is very, very bad. But that's what we can do next, is improve the performance of the searching and then move on. Otherwise, do more heuristics. And we have to implement the chain reactions. And if we implement the chain reactions, that might actually be enough to save a few more. And because it looks like we're dying quite often, and we're still getting stuck in a few situations, but I'm not caring about stuck. It looks like we're dying more than getting stuck. So if we just focus on dying or not dying, that might be better. So I'm going to go over and save this, commit this a bit here, git status, git add. We've done a lot of work here. Simulator. We haven't even added the simulator yet. That must have been a mistake from last time. Git status, git commit. More heuristics. Okay, and I guess that's about all I'm going to do. A bit tired, so that should be it. And we might climb up or down. We'll see wherever it is tomorrow. And we'll see what I do if I have to improve performance. And otherwise, I probably won't be here tomorrow for Coding Game. I will be here then Wednesday or Thursday night, I hope. But tomorrow, early in the day, I hope to be doing Leaf, and I will be doing the Wormies thing. Again, I'll show it. We don't have very far. But the cool thing about this is that this is written in Leaf. This is my language, and this language has made it pretty far. Not as far as Rust, obviously. Rust is much further than that. And the game doesn't do much yet. We're just basically started. Today we fought with GL, and I couldn't get it working. I finally figured out what it was. But that's what we'll work on tomorrow morning if I get a chance. We'll make him eat the dot and grow longer. I thank you very much for watching, and until tomorrow or until later in the week of Eating Rust, I wish you a good night and a good day. Thank you.